Okay, in this video we will finish the section 3.2, right? And this is the page, right? So here we will consider the question 6. Question 6. So question 6, it says describe the relationships between the graphs. So part 1, it says y equal tan theta plus y equal tan theta plus pi over 2. First I will write this and we will see how we are going to tackle this. Part 2, it says y equal cot theta, right? Yeah, and the comparison is this one is tan y equal tan theta, and this one what we have to comparison is the y equal minus cot theta, part 2 minus cot theta, right? Sorry, y equal cot minus theta and y cot theta, y equal cot theta. So the part 3, right, part 3 is y cosec plus y equal cosec theta plus pi over 4, theta plus pi over 4, and cosec theta, cosec pi equal cosec theta. And part 4 is y equal sec theta minus pi over 4 and y equal sec theta. So here actually they are asking describe the relationships. So actually now this is part A, right? This is part A of 6. So they actually to find the relationship we should know only the transformation, right? Only the transformation, and we should identify what has happened. Now this is also a basic thing, please children, there are many few students, now we all have to revise this, right? Now the transformation, if y is equal to fx, right, what would be the transformation of y equal afx and y equal fx plus a. Like this. Here actually what would happen is it will stretch, right? Stretch by taking the x-axis as the the symmetry line, or this is the reflection axis, and it stretches 2 times. All the coordinates becomes 2 times. If it is plus a, it gets shifted. And if you consider y equal fx, right, y equal fx plus a, it's the opposite thing, it gets shifted to the left. So these things I explained well, right? And using coordinates, sample coordinates, you should be able to do it. So now in this case what we have to do is we have to identify what has happened. Now for example, if you take part 1, right, the most simplest one is y equal tan theta, then we can consider this is equal as y equal f theta. That means it's a function of y, right? Now we have to compare y equal tan theta, this is the f theta, with y equal, right, y equal tan theta plus pi over 2. I'll see with the pi over 2, oh yeah, pi over 2, right? So now from here to here what has happened? So here we can identify, instead of theta we have put plus y equal f, right, theta plus pi over 2. So that means from here to here what has happened is kind of this. I hope you can see here, right? This is the transformation of y equal f, right, x plus a. So instead of x we have put x plus a, then actually it has shifted left. So the relationship is, right, we can say the y equal tan theta plus 2 is, right, shifted left pi by 2, right, y by 2 comparing this equation. Right, now we will see actually what has happened here. Right, what has happened here is wait, I'll take the dust. Right, so here what has happened is, now all the transformation you should remember, and you have to map. So here what has happened is, it's like y equal f theta, right, function of theta, and it has become y equal, right, f minus theta. That's all. Right, so this is actually a reflection over y-axis. This is, if you have here minus, right, actually it get reflected. Those things I have explained. Now we can't go for that transformation explanation. So what you can say is, from here to here it is a reflection over y. Now what about this? So again cosec is there, right, only the theta has been replaced by this, so it's like x plus a. So it is again plus, no, that means it is left. You can say it is a translation to the left. Same graph, this y equal cosec theta has translated this y equal cosec theta by translated to the left side, or shifted to the left side by units pi over 4. Now here again sec theta, but minus, then it is the opposite. So if it is minus, it is gone to the right side. Same sec theta graph should get shifted to the right side, but how many units? Pi over 4. Right, okay, so that's all we have. Right, and we'll see what is the part B now. So part B, it says, by considering the graphs of y equal tan theta plus pi over 2, comma y equal cot minus theta. You have to consider these two. Yeah, there are four. There's another one, cosec theta plus pi over 4, and the another one sec theta, like that. So state which pair of functions are equal. So the expectation is, now first of all we have to see what's the approach of this question. So the expectation is, we have to use translations, right, and see. So we know, I know how to draw tan theta, we know how to draw cot theta, we know how to draw cosec theta, we know how to draw sec theta. But when these theta minus pi over 4, theta plus pi over 4, those things are applied, these fellows will get translated, transformed into another, reflection, or shifted or stretched, or like that it will happen. So when these transformations are applied, maybe pair of two fellows are going to be the equal graph. So we have to do the translations and then see actually what are the equal ones. So I will pause the video and I will first draw this tan theta, cosec theta and those things, and then we will discuss how we are going to find the equal ones, right? Right, so this is a very interesting question, right? You have to, you can rewind this part and again see several times. Now what I have drawn is y equal tan theta, that is our normal pattern, right? So here the first line is pi over 2, and cosec theta, actually what will happen is sin theta's opposite. Now sin theta oscillates like this, right, oscillates like this. So 1 over sine, actually the boundary is 1 minus 1, this band, and he goes like a maximum or minimum. That also we know. These are basic shape. And cot theta also, it is the opposite, right? It is going like this. It reaches infinity in the 0 part, right? And in this range it reaches the cot theta, right? So cot theta, yeah, so in this part this is negative, so because of that it flaps. So that means when it is reaching infinity, it reaches 0 but negative value, right? Because this part is getting converted into this, right? So you have to draw these and actually check. So anyway, cot theta looks like this, right? Looks like this. Tan theta looks like this. Cosec theta looks like this. Sec theta. All these four right, are actually little different to each other. But see what would happen now when we consider tan theta plus pi over 2. Actually the whole thing, this is the pi over 2, pi over 2, pi over 2, this fellow gets shifted, right, shifted to the left. If it is pi, because this is the fx, I mean instead of x you will have x plus pi over 2, so whole thing gets shifted, right? So now, but it comes as the mirror image. So when this fellow gets shifted, he comes from here, right, comes from here, but it is not this image. Now you can draw and see it comes here. But the cot theta, I mean this graph question, I mean 2, it is taken the reflection, right? So when it is getting the reflection, it exactly becomes tan theta, so please draw that. And now I gave the help. So my thing is, this one is these two are equal, so what you have to do is draw tan theta and shift it. Now if it is black, maybe blue color you can draw how it is getting shifted, and then leave that graph blue. This also take the reflection, right, reflection over y-axis, and draw maybe another color, green or whatever. So blue and green graphs are going to become same. And same thing happened for now 3 and 4 also. 3 and 4, interesting thing, right? Now actually these minimums and right maximums are there in the sec and cosec, right? They are in different places, right? And right, so see what happens now when we say y cosec plus pi over 4, this is pi over 2, half of that he comes to the left, cosec. So this fellow comes here, this peak comes here, left. But the other one, right, other one, now if you consider the y sec x, right, now this is pi over 2, halfway he will come here. So actually both are going to become the equal shape. So this fellow is going to get shifted halfway, right, halfway like this, halfway, and this one also going to get shifted halfway. So those are going to be equal, same thing. This one is going to get shifted this side, right, and this one also going to get shifted to the other side. So then both becomes equal. Right, actually sec theta is going to get shifted to the right, minus, no, so he will get shifted to the right, right side, kind of this, right? So this range, this fellow will come. So you can see those things are going to be equal. Now we will see the 7th question, right? 7th question also sets the separate axes, these graphs. So first of all we should know the, I mean now tan theta, of course, all right, the tan theta, sin theta, cos theta we know, but we have to know what is cot theta, sec theta and cosec theta. Those graphs also we should have an idea, and then we have to draw, right? So that also maybe, yeah, I will get the help of this, and I will, yeah, so sketch on separate, no, so I will give a help, but I will draw this again and I will come for that question 7. Right, 7th question, for I mean for all I will draw the, I mean tell you what are the transformations you should do, and then I will do some selected questions from question 7, right? First of all, question 7 part A, what should happen is sec 2 theta. So it is the transformation of y equal f ax, right? That means getting multiplied. So part A, what should happen is, now if it is getting multiplied, x behaves in the opposite way, right? If this is the y-axis, he should get half of it. This way he should stretch, right? So the scale factor is, right, scale factor is k is, I mean all the coordinates should get multiplied by half, right? All the x coordinates should get multiplied by half when this is happening. So you have to draw sec 2 theta, sec theta, right, sec theta, and then sec theta, and then what you should do is take all the points onto this one. So part B, what should happen is part B, cosec theta. So it is y minus cosec theta. That means it is the transformation of y minus fx. So if y is equal to fx, this one. So actually this is the reflection this one, reflection. So if this is the x-axis, it will become, maybe reflection. That's all, reflection. So you have to draw the cosec theta and then reflect, right? And part C, what should be the transformation is y equal, right, fx plus a, 1 unit, right? So plus 1. So sec theta should be transformed, right? Sec theta should be transformed by 1 unit up. So if it is the x-axis is here, everything should shift up by 1 unit. We can say scale factor is 1, k is equal to 1. So this is part C, right? Part C, that is y equal 1 sec theta, y equal 1 plus sec theta. And actually this one is part B is y equal minus cosec theta, y equal minus cosec theta. And this fellow is part A is y equal sec 2 theta, right? Now part D is, right, part D is actually y equal, so I will write the equation, y equal cosec theta minus 30, so this is in the form of, right, y equal f x minus a. So then what should happen is it should shift to the right side, right, by k equal 30 degrees, or k equal 30 means pi over 6, right, pi over 6, right? So then that is D. I don't have space to D. E also I will do E. E is, right, E is actually y equals 2 sec, y equal 2 sec, right, theta minus 60, so here, so what should happen is two transformations are going to happen. So first we have to consider, right, y equal sec theta. This is 60, y equal sec theta. So the first transformation you can have y equal fx minus 60 or fx minus a, right, fx minus a. And the second transformation is after happening that, so minus 60 comes twice as that, y equal to fx. So what should happen is, for this, if it is minus, he should, sec theta should get shifted to 60 degrees, k equal 60 or pi over 3, k equal pi over 3. That much you have to get shifted, first fellow. And if it is 2, it is getting stretched 2 times. All the y coordinates are getting 2 times. So both things you have to apply together, right? Okay, so the F part I will erase the board and draw, right, F part, right? So this is question 7, part F, right, part F. Here what is going to what has happened is, right, we can start it from y equal cosec theta, right? You can have either way. First transformation, what you will do is fx, y equal fx, right, y equal fx is there, that is going to become y equal fx plus a plus a. So this is going to be a shift to the left, that is pi over k is equal to pi over 3, that is 60 degrees. And the second transformation, so now we got the 60. Actually I was wrong. So first what we have to do is this 2 theta should be done, right? So I was wrong here, otherwise we are in trouble. Otherwise you have to take 30 and then multiply by 2. So first transformation we will make it 2 theta. So we to make this one to y equal cosec 2 theta, right, we have to apply y equal f ax. That means it is the whole graph is going to become, I mean, if this is the situation, I mean, it stretches towards the y-axis. So k would be 2 half scaling factor, all this one is getting, then we get this. So this one, to make it y equal cosec 2 theta plus 60, right, 60, what we should consider is y equal f x plus a. So I mean, after drawing this should be shifted left. Plus 60 means shifted left, so whole graph will shift 60 degrees. K is equal to pi over 3, right? So that is how you handle the f. And to do part G, I will again erase the board and do. Right. So here what we have to do is we have to start it from y equal cot theta, right, cot theta, and then I mean, you can do this transformation in any order, right, any order. So the first transformation you should do is I mean, I will consider y is equal to f2x, right? So we can say f(ax). So what would happen is, right, the cot theta graph, right, cot theta graph, this is the graph. What would happen is, right, so if it is a, again stretches towards the y-axis, this is y-axis, and it is k, the scale factor will be, if this is a, now we are going to make it y equal cot 2 theta. So the, if this is one over this one, that's know how x behaves. So here k would be half, right? Okay, now again we have to go for minus. So to make it y equal minus cot 2 theta, then we have to apply the transformation y is equal to minus fx. So this is the, I mean, this is where the y coordinate gets changed. So it is a reflection, right, reflection over x-axis. So all the y coordinates here should go to the negative. Negative ones go to the positive. Then you can get that graph, right? So now we have the last one, h, that I will do after erasing this. And after doing that, selected difficult ones I will show, right? Don't worry, I will show the difficult ones out of the grades, I mean question 7, right? So part A, part H, our focus is, right, focus is we have to go for y equal 1 minus 2 sec theta, right? We have to go for this. So we will start from y equal sec theta, right? So to get 2 here, right, actually we can have the scale of minus 2. So we will use again from here to here, right, y equal afx. So what would happen is, right, now since this is a negative fellow, right, now minus 2, no, right, minus 2, I will I mean, what would happen is actually it will change the sides, plus it will get stretched. For example, both will happen when you are considering y minus, or else we can do like this. We can have two steps, then easy, no, you can understand that, right? So here first case we will do like that. We will have minus y equal minus sec theta, right? So we will have the transformation y equal minus fx. So this would be, right, this would be actually a reflection. If this is the x-axis, it will be a reflection. So the graph should be flipped upside down in this. So we get minus sec theta, and then now we have to take 2, right? So we will apply y equal, right, afx. So now this is a positive value and it should be 2. So when you get multiplied by 2, you will get, right, you will get y is equal to minus 2 sec theta. So in this case a is 2. So what should happen after flapping? There will be a graph. That graph, right, now 2 times. So it should stretch like this. All the y coordinates should get doubled. If it is positive, positive double. If it is negative, negative double. So it will stretch. So then we will come up to this place. Then finally we should have this. So then for that we can have, right, for that we can have y equal, right, a plus fx. So that means everything is getting shifted up. So after this, right, everything will get shifted up. That means actually plus a, fx plus a shifted up by 1 unit. So that one I will show you. Definitely h I will draw the graph and show. So it should get shifted up by k, you can say 1, right? So now I select, I will do some difficult questions. I feel EF GH, I will do EF and H, right? EF and H I will do on the board, and you can also check after doing that, right? So this is the sec theta graph. We will check now. Sin sec theta comes from cos theta, right? Cos 0 is 1, cos 0 is 1, then that's all right, and this part get goes to the top because this is reaching 0 and he is going to get a 1 over 0, that is infinity. That's also right. So this is the sec theta graph. Now if you are going for sec, now if you are going to apply 1, right, from here to here, we are going to apply, right, this graph, we are going to apply this one. So this is going to be y equal then sec theta minus 60. That means we are going to apply y is equal to fx minus 60. Fx minus 60. Then if it is minus, the x transformations I told, it behaves opposite, or then whole thing gets shifted to the right. So now this is this is what would happen if we apply, right? This is what would happen if we apply, right, y equals, right, if we apply y equals, right, y equal fx minus 60. That means here you should go 60 degrees to the right, everything, right? So what I did was, now here 90 is there, no, right? When you add roughly, when you divide this, this is always 90, vertical lines, the angle between vertical lines, and I divided by to 3 parts. So one is 30, 30 like that. So 60 you have to go. So always 2/3 I went, 2/3 I went, 2/3 like that. I put a dotted line. So those boundaries are from here 0, 60, right? New boundaries are 60. This is 60. And this one went to 150. So here 0, sorry, yeah, so yeah, this was 90, 60 added, this is 150, right? And here it was 180, another 60 added, 240, like that. All these red dots, red dotted vertical lines came. And then what happened was, now earlier it was this, it was like this. here, but he got shifted 60 degrees, 2/3 he went from this gap. So all the curves, I mean the sec theta got shifted 60 degrees. So that is how you get. And to apply this, right, to apply this, now finally what we want is 2 sec theta. Now this graph you should multiply by 2. So here -1 will become 2. So our new boundary will come from here, and all the fellows will get shifted, right? So again I will draw the new one kind of this, like this, right? So this also will get shifted, I mean 2. So first we have to draw the this is -1, then minus plus 2, and -2 also we have to draw, and it get spread out. So please draw this and practice, right? So the two transformations you should do is you should shift 60 degrees to the right and stretch the curve 2 units, the scaling factor. So here this band, this is 1 and -1, it becomes 2 and -2. That's all. And this actually comes from infinity, -infinity, and touches the 2. Here also it comes from -infinity and touches 2. So likewise you have to do. So then this graph you can draw. Now we'll check another one graph. Okay, so what would happen is, now I have here what I've considered y equals sec theta, right? Sec theta is actually from here 1, this is 1 -1, right? And this is the shape, that is our normal scenario. Now what would happen if we are going to take y equal minus sec theta? So y coordinates get multiplied by minus, so flipping, mirror image, reflection of this. So this graph will come to this side. So whatever it was here, now it is down side. So whatever down, it came up. So what happened was flipping. So this is minus sec theta. And also to this minus 2x, what you should do is, now this is transformed. Now this should be multiplied by 2. Now here what we applied was y is equal to minus fx. Now what we have to do is we have to apply, right? Still we didn't come for this. This is y equal, we have to make it 2 sec theta. So the transformation what we should apply is y is equal to 2fx, 2 times, right? 2 times. So then what would happen is, all the y coordinates, this one will go, bottom, right? So what the easiest way is, so I will make this one minus 2 sec theta, and I will make this one 2. So that means everything went up, got stretched, right? So -2. But you all better one, because you are doing for the first time, you draw each step. And then now I can do this one. I will erase this, right? So I can call this y is equal to minus 2 fx, right? -2. So actually 2 transfer, flipping plus stretching. So this became 2. Now the other one is actually to get y equal 1 minus 2 sec theta. What you should apply is y is equal to fx plus 1. So if you add plus 1, you will get 1 minus this one. So what would happen is, everything will go up. So that I will draw, and again I will on the video, right? I will pause the video and then draw that and on. Right, so what has happened is, now when you are coming from this diagram, it's totally little messy. I hope you will understand, right? We have to draw your own graph and see. Now when you take the theta axis, -1 is very close. Now when everything shifts up, right? Sorry, this becomes 3. 2. Right, 2. 1 1. Here actually I considered 2 and 2, 2 and -2. So this becomes 3. This becomes 3. So when you are shifting up, this axis goes for 3, this -2 comes for -1, this -2 comes for -1. So this dotted line should be closer to the, much closer to the x-axis than this dotted line. right? So that sketching in that property should be there, and what should happen is this should shift up, that's all, and it follows the same boundaries. So here it is, we took as 90, right? 90, 180, like that, again another 90, 270, 360, like that, minus 90, you mark those, 0 is here. So this is how you do, right? Now I think seventh question is okay. Right now I will see whether we should, what are the things, other things we should do. Maybe the 9th and 10th I have to see, right? Okay, I will pause the video and then again I will do the rest. Question actually, now I want to explain how to find the period. Right now, if you take, this is the sine graph, right, and cos graph also opposite, I mean like this, it goes oscillates. So in this, actually the period is now physics also we take that, what is the period of this period is, now when it starts from 0 and it goes down, right, it starts the journey when x increases, right, from where it goes down. So same behavior now, although this is 0, when x increases, it going to be a positive value little bit later, here negative value. So this behavior and this behavior is totally different. So again the same behavior comes here. So the period get repeats, I mean the values get repeated after this period. So that is minus pi over 2, pi over 2, that is pi, right? So for all cos theta, right, sin theta, tan theta, right, and cot theta, right, all the cot theta, those things, cot theta, tan theta, cosec theta, sec theta, all they will have the same period, right? Now now we have to be careful. In question 8 they are asking about sec 2 theta, sec 3 theta, right? So again it's like this, if you take sin theta, right, sin 3 theta, so what would happen to this graph? Now here, I mean, we will mark pi over 2, we will mark it 90 for, I mean, to make it easy, 90 degrees minus 90 degrees. So sin 3 theta means now x value got multiplied by 3, so it becomes 1/3. So here 90 get 1/3, he will come up to here. He will come up to here, minus 90 will come up to 1 over 3 is 330, minus 30, minus 30, minus 30, and the new graph, right, new graph will look like this. New graph will look like this. This is actually so here like this, like this, right? So what would happen to the period if this becomes 3, it gets shrinked, right, x-axis. So then this is now this is 30, 30, right, 30, 60. 60 means pi over 6, right? So same way sec theta also, if it is 3, it will be pi over 6. So you can draw and see, it just comes to that, right? But your job is to draw. Now the other thing is, we have I mean, if you consider sine half theta, so that means this fellow get doubled, this fellow get double, so it will go to 180. So if this is pi over 2, it will become pi. This fellow also will go to minus pi, so 2 pi, right? Like that you have to see how it is, what are the things going to happen. But now I put the answers, right? Then you can visualize the graph and see. Question 8 part A, they are considering sec theta, sec 3 theta. So our normal is pi, 3, no, then pi over 2 divided by 3 is pi over 6. 2 of those is pi over 3. So the time period is that. Part B, cosec half theta. So then it get doubled. This also double, this also double. So normal is pi, right? This is pi, right? Pi over 2 becomes double pi, then 2 pi, right? 2 pi. Then part C. Now this is interesting. 2 cot theta. 2 cot theta. So if we consider 2 sine theta, right? 2 sine theta, what would be the period? The only whatever period remains the same, only the magnitude get changed, right? So the repeating, this behavior repeats after that, but it gets spread this way. So nothing happened. Our normal scenario pi. Our normal graph is pi over 2, that is pi. So we can say this is pi. So same, if we 2 cot theta, same. Part D, sec theta, sec minus theta. That means, I mean, whatever graph is there, sec theta he is getting repeated with pi, but minus theta is, it is getting reflected over y-axis. He is switching the sides, right? So this again still same pi, right? So that is how you handle the 8th question. 9th and 10th also I will do. It's little difficult, but still it is very interesting. Right, now this is the 9th question of page 53. So we have to consider 3 plus 5 cosec theta, right? So what I mean by looking at this is our cosec theta, right? Cosec theta, and it is like here pi over 2, pi, like that, it shapes like this. Now 5 cosec theta, what would happen is this minus 1, actually, I mean, this is minus 1 coordinate, this is minus 1, all will become minus 5. These plus 1s will become what? Plus 1s become plus 5. So if you consider 5 cosec theta, I mean, it will get stretched away from the x-axis. So because of that, and then this will jump to minus 5 and this will jump to 5, but again we are shifting it 3, so this 5 will become 8. That is why I have put 8 here, and this went to minus 5. No, another 3 units he will come. So the shape will look like, now this is this one, right? So same scenario, pi over 2 he will have the minimum, like this we have to draw. So this is the graph we should consider, right? This is the graph we should consider, right? This is 5 cosec theta plus 3. So right, now what we have to do is, now part A is actually this sketching. Part B they say, right? Part B they say this equation, part B, 3 plus y cosec theta equal k. Find the k values which will make this equation has no, then for the, what are the values which sorry, right? So we have to find the k values, right? For those values, this equation should not have solutions. So what should happen is, now graphically if we think, what we have to do is, we have to find the solutions of y equal this one and y equals k. So k is a constant, so always y equal k is a horizontal line. So what are the k values which will make this one has no solution? So the k value should be between, less than 8. Even if you take 8, it will touch. If you take this line y equals k, we will dotted line, with a red line we will draw a dotted red line, right? If you take a dotted red line, now this is y equals k. So if you take k equals 8, you will have solutions. K equal minus 2, you will have solution, but between those two values. So part B, the answer is k should be less than 8 and greater than minus 2. So for these values, this equation will not have solutions, right? So that is the question 9. And this question 10 also very interesting. I will do on the board, right? I will pause the video. Right, 10th question, they are asking us to sketch this one, this 1 plus 2 sec theta in the range of pi minus pi to 2 pi. So here I have to minus pi, so we don't need this, right? We don't need this, we will erase, right? We will erase 2 pi. So now if we take sec theta, we know now this is pi over 2, pi, 3 pi over 2, like we know the shape is like this, right? And again this one. So this is sec theta. So to get now here minus 1 and 1, minus 1 and 1, that is now obvious. So actually now I took 3 and minus 1. So how did I take that? When you take 2 sec theta, that means 2fx, it's getting stretched. This minus 1 will jump to minus 2, this one will jump to 2. And plus 1 means shifting everything up. So minus 2 will come to minus 1 and plus 2 will go to 3. So graph is like this. So this boundary, minus 1 boundary, it will jump, this one will jump to 3, this will jump to 3, and it will be the same shape. But this is like a little more, no, same shape, yeah. It's little stretched more than that. I mean, if you compare these two graphs, it should be a little stretched, right? But it holds the basic. So here I will put it in red color, right? Like this, and here like this, and again he will come from this side, yeah, like this. He will go and he will touch here, and till 2 pi we need, no, right? 2 pi he will have the minimum. So here like this. So this will be the shape of one. So then the part A is over. Write down the theta of points which the gradient is 0. So now this is part A sketching, okay. So part B, what are the points? So in this range, what are the theta values which the gradient is 0? So gradient means our tangent. So when you take the tangent gradient becomes 0 at these minimum points. So what are the values? Theta is equal to what? Minus pi, and again 0, right? 0 and pi and 2 pi, and those places the tangent's gradient becomes 0. And another thing, now they say deduce the maximum and the minimum values of Happa. But although this looks like a difficult question, right, it is easy, right? I will do that part here, right? So here what we have to consider is 1 over 1 plus 2 sec theta, minimums and maximum values of this, right? Now if you consider, right, if you consider this graph, what are the points of maximum and minimum points are this, but pi, minimum. So out of this minus 1 is the minimum, 3, and this no, minimum is again minus in infinity, minus, no, minimum. Maximum also you will have this one, so we can't talk about that. But part C, if you consider this, right, so he will be in the range of, right, x will be in the range of x. Now if you take this y, right, now this y, this will be always 1 plus 2 sec theta greater than or equal to 3, right, or 1 plus 2 sec theta is less than or equal to minus 1. This quantity, right, these two quantities. So now I am going to erase, at least this part to explain that, right? So assume this graph is there. If you want, you can rewind and see, right? Now what we will do is, right, what we will do is we are going to handle the part C. So part C we can see, so if this is the case, what can you say about 1 over 1 plus 2 sec theta, right? It will be always, right now it's a greater value, no? It will be always less than or equal to 1 over 3 if you consider this, and it is a positive value, so it will be less than. That means now when he is here, right, 1 over this value is 1 over 3, here it is 4, then 1 over 4, a little smaller, always smaller, and finally when he reaches 0, this one becomes bigger and bigger when theta goes. So always this is less than this one, right? And if you take this part, right, it is always, right, if you take this one 0, 0, then right, I will pause it and put the relationship, right? So if you take this portion, right, we can consider this. So if it is minus 1 over minus 1 is minus 1, and when it becomes minus 5, it is minus 1 over 5. So that is going to be this one great, if you take this one, it is going to be greater than 1. We'll check that again. I will pause the video. Right, so what we can check here is, now if you take these values, he will have 1 plus 2 sec theta, here is minus 1, and little bit later he will be minus 2, and little bit later he will be minus 5, like that. He keeps on reducing. But if you think of the what you call this inverse, right, reciprocal of this, right, it will be minus 1 over 1, that means minus 1. So, and when it becomes minus 2, it will be minus half, the reciprocal of this, right, minus half, and then minus 1 over 5. So it is getting smaller. So this is the sorry, you can't see that. So here, smaller means the size wise, but because it is negative 1 over 5 is bigger than negative 1 over 2. So this fellow is always greater than minus 1 or equal to. So we have two fellows, right? This is greater than or equal to this one, and this is less than or equal to this. So what they ask is, right, what are the places where you can have the smallest positive value of theta, right? So maximum and minimum value of. So what would be the maximum of this? So 1 over 2 plus sec theta, right? So what you can see is, if you take pi, right, pi, now this is always greater than or equal to minus 1, right? So this is a minimum point. What is the minimum point means? Now if you now I have not drawn, but if you draw, surely what should happen is 1 over 3 will be always minimum point, right, because it is going to be a greater and greater value. So here minimum point would be 1 over, because it is greater than or equal to. Now here always this is going to be less than 1 over 3, so that is going to be a maximum point. So, and also what are the places? So we can say talk about max will occur when it is 1 over 3. 1 over 3 means pi theta is equal to 0, right? Theta is equal to 0. Minimum will occur, right, when theta is equal to, so here minus 1, this place, right? Theta is equal to pi. Yeah, so only one place pi. Theta is equal to pi, right? Okay, so that is the idea. And then another one, they ask give the smallest positive. So all these values are going to be negative. Greater than -1 means -half, minus I mean this side of the graph you will get -half, minus 100, like that. It's get smaller and smaller, but always negative. This is the positive side graph when you take it. So, and it is going to be smaller, smaller. They are asking the smallest. Yeah, so this is that's the trouble. Smallest positive value of theta. Smallest positive value of theta. Okay, children, so the smallest positive value of theta. So they expect in which side it occurs, right? So here, right, theta equals 0 and theta equals pi. Okay, that is the answer. And when theta is equal to 0, what is the maximum value? It is 1/3, right? What is the maximum value? It is 1/3. 1/3. And what is the minimum value? It is -1. It is -1, right? It is -1, right? Okay, so I think we did that 10th question. Now in another video we will jump to section 3.3, right? Section 3.3. Section 3.3, right? We will stop here.